Hey Pre-Calc, I'm here with another video on how to use the TI calculator to solve inequalities. Now in class, we took a little extra time to learn the calculator because I learned that a lot of students hadn't used the calculator very much in prior courses, and that's okay. So we took a little extra time. I actually showed you everything you need to know to solve these, but there was a couple examples I didn't get to, so I'm going to do them now. Okay, so on the screen you see an example. In it, this one is actually not in your notes. I planned to do this as a whiteboard activity, but we didn't quite have enough time. So in your notes, if you have those open, like pause the video, get your notes, and get this because you could write down these results. Okay, in class, we solved this equation with the calc intersect method, and now we're going to solve this inequality with the calc intersect method. And reminder, the way we do it is we graph the one side of the inequality, like y1 equals the left-hand side and y2 equals the right-hand side. Now what you will see, we'll graph it more precisely in just a second, but this is a parabola that looks like this and a line that looks like this. And we're going to look for those intersection points. And so y2 is going to look like this. y1 is the parabola. And since we want everywhere where the parabola is greater than the line, we're going to look for all parts of the graph that are above the line. Well, this part of the graph is above the line. This part of the graph is above the line. That corresponds to all the x values to the left of this intersection point and all the x values to the right of this intersection point. So we just need to find the x coordinates of those intersection points and we have our solution. Okay, let's switch over to the TI calculator and then I will do that. And I'm going to just slide this over slightly so I can see, let me just slide this over slightly so I can see that inequality on my screen. I slid it too far. Okay, there we go. I can see it on both screens. Okay, so I have x squared minus 2. So I'm in my calculator now. So get your TI calculator and do this with me. And I'm gonna go to y equals, and I will graph the left-hand side. So that would be x squared minus 2. I'll go down to the next equation and I will graph x plus 4. Now let's jump over to the graph, and I don't have to adjust the window at all because I can see the two intersection points. Reminder that to find the intersection points, you hit second calc. That's pressing the trace button, but above it is CALC, that's calc. We hit that and we want to go to the intersect function. You can hit the down arrow to go to it and hit enter, or you can just hit 5 and it will jump to the intersection feature. Okay, remember it asks what's your first curve, so you pick one curve so you need two curves to intersect, and so it wants to know which two you're evaluating or analyzing. Okay, so I'll hit enter. And then on the second curve, I'll hit enter. And now it asks for a guess. The reason for the guess is it's going to need to know which intersection point you're looking for. There's two here. So by putting the cursor, I can hit the left arrow. By putting the cursor closer to one of the intersection points, it'll find that one. And on the bottom, it gives you the coordinates of that point. So I'm going to write that down. You'll be able to see it like on the right-hand side of the screen. One intersection point is -2, 2. And the other intersection point is, so I'll go second calc, 5, first curve, second curve. And now I put in a guess. It's about, do you see how it's at about x equals 3? Instead of hitting the cursor all the way over here, because that takes a long time, you can actually just type the number 3, and that's pretty close. And we got, actually, that was exactly correct. So the intersection point is 3, 7. So now that I've done, that's all the calculator work I need. I come back here and I notice that the coordinates of, oops, did we do that? So now I see that the coordinates of this point here are -2, 2, and the coordinates of this point up here are 3, 7. Now, look at the inequality. X is the only variable in this inequality, so we're looking for X values that make it true. I'm just using a 2D graph to find the intersection points, but I actually only care about the X values of these intersection points because this X value is -2, this X value is 3, and we want to keep all of the graph outside of those points. Remember, because we want where the quadratic is above the linear equation. And that's the part that's up here and the part that's up here, and that corresponds to the X values on the left of this boundary and on the right of this boundary. So our final answer is the following. Everything from -infinity to -2, not included, union 3 to infinity. Okay, let's do one more. So this is an example of a parabola where we are going to solve this inequality using the Calc 0 method. Well, what you'll do is you will graph this, the left-hand side. So by the way, notice we got 0 by itself on the right-hand side. So when you have 0 by itself, you don't need to graph both sides, just graph the left-hand side. And that's x squared minus 5x plus 6. So I'm going to go over to the calculator, and you can clear out your the graph that we already had. So I'll go to y equals, I'll hit clear, down, clear, go back to y equals, and that is, I'm going to clear that. I'm going to go up to y1. The equation that the inequality we were solving was x squared minus 5x plus 6, and we're trying to find where that quadratic is less than or equal to 0. So I'll look at this graph, and we'll notice that it seems to hit the x-axis at 2 and 3. Now, it was a simple one to factor. We could have figured that out, but we're just practicing the calculator here. I'm going to zoom in closer to this, and I'm going to pick my x window to go from -1 up to, say, 5. So I'm going to do window, -1 for x min, and for x max I'll do 5. And let's look at that. Okay, great. You see how it zoomed in on this area. If you want it to take your x interval and fit the rest of the graph to it, you can actually hit zoom and go down to fit. Zoom fit, and zoom fit fits the y values in that interval that you just chose. But I think I will actually I'll zoom out a bit so that I can see, whenever you zoom out, you then pick a place where you want to zoom out. So a center point. So I'll move it down a little bit, maybe down here, and I'll hit enter, and that's okay. That should work. Actually, since I'm showing you some zooms, if you hit zoom, you can actually do zoom box. That's the first one. Let me show you how that works. Zoom box allows you to put a box around whatever you want to see in the window. So notice I put my cursor here. I'll hit enter. I'll go down and then to the right. That seems like it's going to show me what I want. And then you hit enter and it resizes the screen to your box. Okay, so now back to what we were solving. We're trying to solve for when this quadratic equation, we're trying to find when this is less than or equal to 0. So I just need to find the intersection points. So I hit second, calc, and I'm going to use calc 0. Calc 0 finds the x-intercepts. Now remember, it asks for a left bound and a right bound. So we want to put boundaries around this left-hand intersection. So I'm going to put 1.5 for a left bound and 2.5 for a right bound. So it's going to look for an intercept between these two boundaries. I'll just hit the left arrow a little bit so it's kind of close, and that's my guess. It gave me 2, 0. So I'll write that down, 2, 0. Okay, now I'm going to find this other intersection point, second calc, 0, left bound, 2.5, right bound, 3.5, and I guess anything in the middle will be just fine. Hit enter, and I get 3, 0. Okay, now back to here. So I did my calculator work. In fact, what you see below here is what we just saw on the calculator. So we found that this coordinate, this x value here is 2. The coordinates are 2, 0. This x value here is 3. The coordinates are 3, 0. And we want wherever the parabola is below 0. So we just want to keep this part of the graph, or we're interested in this part of the graph, and that part of the graph, it corresponds to all the values between 2 and 3, and it includes the endpoints because it's or equal to. Okay, so the answer would be 2 to 3 inclusive. Okay, there you go. You saw how to use calc intersect to solve an inequality with the calculator. You saw how to use calc 0 to solve an inequality with the calculator. And oh yeah, just one comment. If you get an inequality where you have terms on both sides, if you want to use the calc 0 method, you need to subtract or add terms so that everything gets on one side. To use the calc 0 method, you've got to get 0 by itself on one side. So in other words, we would need to subtract this 2.0 and we would need to add 1.4x to both sides. But I'm not going to do this one. I just wanted to remind you of that. We did it in class as well. All right, see you in class. Bye.